for taking time to attend this presentation. This would not have been possible without encouragement from Midori. So I should acknowledge her for providing the impetus to move forward and encouraging me, hey, why don't you formalize this and pen this down? So it came off as a little bit informal presentation, but started taking shape over time. So thank you very much, Midori. Thanks for the kind words and everybody for taking time to attend this presentation. So I'm just not going to do the, should I do this kind of, I won't be able to see you if I put full screen. So what would you like me to do? Do you want me to go full screen or can I keep it this way?
It's up to you. Right now, I'm not seeing slides at all. Are people seeing slides?
Oh, okay. So I should have done this. Are you able to hear me?
Yes, we can hear you, and now I can see your slides. And
okay.
This works, or if you, yeah, this is great.
Okay, great. Thank you so much. Thanks for the kind introduction, Sonali, and thanks for inviting me to share some of my thoughts on this topic. These are extremely involved topic and very complex areas. It seems to be evolving rapidly by the day. So I'm just grappling, trying to come to terms and trying to catch up. So I consider this opportunity more of a learning experience rather than me educating somebody or something like that. So I just want to be very careful. I know that there are lots of experts in this presentation, so please feel free to share your thoughts on the topic. So just see whether this moves. Yeah, there we go. So we'll talk about definitions. This would be helpful for people who are not familiar with this area. Then we'll get into the core of the presentation, which shows the equity and economics of LLMs. And we will present 3 onboarding pathways, as Sonali had mentioned. And then finally wrap this up by discussing the risks and benefits. To the right is the recent paper. We started off as a white paper because we didn't want to have any word limits and other stipulations from journals. So we wanted to be free thinkers and we started penning down, but after that, there was some mention, why don't we just submit this as a perspective? So there is the original version, which is the passionate version, and the website, JMR website, and there's also the journal version. So this is a collaborative effort between healthcare leadership and people like Midori Kondo participating and helping us, assisting in the process of shaping this, and industry partners, Amazon Web Services, as well as academic experts. Definitions. So there are several definitions of artificial intelligence. We won't go into grueling detail as to which is the right definition, but from an operational standpoint, we can say that it relies on Turing tests, the ability of machine to imitate human intelligence. Sometimes behavior is also thrown into the mix. And machine learning is the ability of machines to learn from experience. We learn from experience, so do machines, on specific tasks, and such that their performance improves ideally with experience. And all these are kind of, very involved. So I'm just giving a layman definition. Kindly bear with me on that. So deep learning is a subfield of machine learning with emphasis of learning multiple layers. And there's neural networks, for instance. So you have the input-output layers and several hidden layers. The number of hidden layers are also kind of reflective of how deep the network is. And these layers have been argued to represent increasingly meaningful abstractions of the input patterns. And the related areas definitely are transfer learning and, as was mentioned, foundation models that you're all aware of. So that's been getting a lot of traction of late. Large language models, which is what we'll be talking about in this presentation, harnesses a specific type of deep learning architecture called transformers. I'm sure that there are others, but the popular one is transformers, and learns the patterns from the given text in a self-supervised or autodidactic manner within an augmented framework, more specifically reinforcement learning. So to the right is a figure that shows the hierarchical nesting of these areas. And this brings up the question, so what do we mean by augmented? So, so here are 2 possible scenarios that can arise within the augmented framework. One is shown on the left and poses a question can domain experts in partnership with the AI resource lead to better insights than those unassisted? So this essentially relies on Charles Friedman's fundamental theorem of biomedical informatics. So healthcare data are typically high dimensional. They're multimodal, ingested from several sources. You can have imaging data, clinical narratives, and physiological signals, and other types of data sets, numeric data. So, and seems to be evolving rapidly. So we have patient-reported data and other types of data getting into the mix. So these in turn can challenge manual interpretation. So in this case, can we have an automated assistant like an AI ML resource that could assist in decision-making overall? So the primary driver is shown to the right of the inequality. On the left is the humans in this case. The other scenario is shown to the right, where you have it poses a question: can AI models with feedback from domain experts perform and generalize better than those unassisted? So after all these algorithms subscribe to optimization in some manner. So if we can reduce the sample space and reduce the number of variables, the search for the solution becomes much easier. So that in turn is expected to improve the performance of these algorithms and generalize also better. And within this specific LLM context, we have guardrails and things that needs to be imposed as a part of prompt engineering and other things, so that goes into the development of the model. So human feedback, it becomes extremely critical. So large language models. So what do we mean by large language models? We've been using this term LLMs, large language models. So the language model essentially assists in predicting a sequence of text in language that in turn may incorporate its grammar context. The latter two is fairly challenging. So developing such models can be especially challenging for natural languages, and popular approaches definitely include statistical models as well as neural networks. So what do we mean by large language models? So these are language models that are large. That's a simple way to say that. So what do we mean by large? They're definitely large in the size of the training data used to train them. So this could run into terabytes of data. And in terms of model parameters, unlike classical machine learning like support vector machines and other logistic regression, so here we are talking about billions of parameters, so very different from shallow machine learning algorithms. And in terms of computational complexity, so these models definitely require specified hardware to kind of address the computational demands, such as hardware accelerators, for instance. The popular ones are graphics processing unit. And in terms of budgeting, so we'll discuss the budgeting for training a large language model. This can run into millions of dollars, so who can afford it and what can be done with it? And architectures that support large language models include transformer architectures. Okay. So why bother about large language models in healthcare? Are we wasting time talking about this? Definitely not. So conversational AI is coming up in a big way, and there's a lot of applications in healthcare, and these fly under different flavors, chatbots, and the summarization tools, as well as translation tools. Many of these are currently being implemented at CHOC. So when it comes to equity and economics, we have the needs, what we want to do, what we need in a health system and healthcare organization. And we also have the affordability. So can we afford these, or is this way too expensive? In which case, is there a single one-size-fits-all implementation pathway, or do we need to have different pathways for strategic and equitable adoption? So important question. So with regards to essential ingredients that typically apply large language models, first is definitely digital readiness. Do we have access to digital healthcare data? So are we digitally well poised to kind of even embark on this journey? So especially critical when we want to train LLMs from scratch. And do we have data governance, enterprise data warehouse in place? This in turn kind of entail upfront cost, and teams need to be supported. And do we have data-driven and evidence-based culture? Is your organization well poised, and is there some kind of precedence where you have demonstrated outcomes to executive leadership in terms of using these models and impacting outcomes and key performance indicators? So these things essentially facilitate further investment and support of teams. They become comfortable. So not all healthcare organizations are mature or well poised, but these definitely go a long way, being digitally well poised. So next we have the infrastructure and workforce. So these are, like I mentioned, it's not like traditional shallow machine learning models where we install a Python or a R package and we start working on those data sets. These are fairly involved, so we have scalability challenges when it comes to this. So horizontal scalability, which is definitely can be addressed on-prem using network attached storage and other types of hardware equipments. But then we also have scalable horizontal storage more from memory standpoint in the cloud. So compute vertical storage is definitely challenging. I can't add a hard disk in a similar manner. I can't just add GPUs to an existing GPU pod or cluster. They require extremely fast communication links so they don't encounter bottlenecks like NVLink switch and other things that you might be aware of by NVIDIA to orchestrate the communication between the GPUs themselves. So vertical scalability kicks in, and it's fairly challenging. And then do we have the workforce? So with expertise across a spectrum of areas, such as artificial intelligence, maybe natural language processing, protected time for healthcare domain experts, nursing teams, providers, and other staff in healthcare workflows to participate. And do we have seamless interface to healthcare IT for productionizing these models? And also, we need to address the ethics, privacy, and regulatory aspects because we are dealing with PHI data in healthcare for the most part. So do we have infrastructure to ensure privacy, adhering to compliance, and do we have the necessary guardrails for protection from bias and discrimination? So digital readiness, definitely there are disparities. Was there a question?
Yeah, Radha, there's a question in chat. Sean, do you want to ask it?
Sure. I think in the context of the large language models, I think there's a huge role for the agent. And I wonder if you could speak to how the agent and the LLM interact, specifically in the context of the context window, and how the agent supports large language model prompt and response processing.
Yeah, absolutely. So that kind of kicks in the fine-tuned model. I completely agree. So the prompt engineering goes a long way, and it's very important to tune the model and customize the model to the needs. So I completely agreed.
So a bigger context window is better?
Excuse me?
A bigger context window is better?
I'm not very sure about that, but prompt engineering is a big part of implementation. So I haven't played around much with the prompt engineering part. But I'm sure that there is lots of factors that go into it. The size of the prompts themselves. When we kind of use some of the cloud infrastructures, they do charge you based on the prompts. So how the more detailed the prompts is, from what I had seen, the better the response of the models are. So the more generic the prompts are, then the models can run into certain more diffuse way of performing, so not being very specific. So the responses might not be very helpful. So the more specific they are. So in terms of how large the prompt should be, there needs to be some kind of a training that needs to be involved in users using these tools. So during the training process, they need to be advised as to how they want to prompt these models. Does that answer your question in some way?
Sure. I apologize. The whole thing is that, we're thinking of capacity in the context of tokens, right? And so the context window is managing the tokens anywhere from like 4K to 131, megabytes and stuff like that. So a lot of the what differentiates ChatGPT versus Anthropic versus Llama 2, stuff like that, or Llama 3, is really the agent and its ability to capture and provide within the prompt all that extended information in the context window. And with things like Google Gemini, where they have a massive context window, it gives it a lot more context of the questions and just kind of how that compares for how not just the size of the language models, but also the size and the processing of the agents.
Absolutely. There is actually a lot of emphasis that it might not be necessary to train these models from scratch, and the prompting that you're talking about, increasing the context window and kind of interacting with the model to make them better would be a better choice. But I still do not believe most of it, but I completely agree that the more context you give, the better the performance would be, but there would be a cost that would accompany the size of the context window. I'm not sure how Google Cloud charges for Gemini, but usually Azure, Microsoft Azure does kind of take into consideration the size of the prompts and the context windows that's been provided, whereas Amazon Web Services has some kind of a flat rate. It really doesn't matter the size of the context windows. Yeah.
Great, thank you.
Thank you. So digital readiness, definitely there's disparities, and so these manifest across different dimensions. So there's genomic disparity in molecular data that's been housed. So all of us, one of the biggest national initiatives, show this skewed distribution across ethnicities. Then there's disparities in access to technology, and then there is disparities as a result of income variation between population, and disparities as a result of geographic variation, urban population, and rural population, and technology ownership and adoption. So all these play a very important role. So in the digital data and digital footprints as to what goes into training these models. So definitely digital footprints and disparities is multidimensional in nature. So that in turn impacts the sample size of those specific population that go into this training data. So multidimensional because we have ethnicity, race, and then we might have rare disease. We might have treatment regimens, novel treatment regimens that might not be adequately represented, gender identity, age, geographical locations, language barriers, social determinants. Some of these actually fall under social determinants. So in fact, if we take this multidimensional perspective and project this, we might have sparse representation of certain subpopulation that in turn can impact the performance. So this raises an important question at this point. Are we digitally poised to implement LLMs? So we talked about digital readiness. The next one is infrastructure. So to the right is a typical motherboard as to what it looks like under the hood in your computer. So we started off with a lot of ecosystems and unified architectures coming into place with the MapReduce paradigm and Hadoop coming into picture around 2006, where there was so much emphasis on distributing data. This is a little different from classical high-performance computing, which talks about distributing computation within a message processing interface or parallel virtual machines. So here we are talking about distributing data. So then there were some efforts in distributing computation too, but the iterative aspects of computation for machine learning didn't gel well with Hadoop, and the performance was not great. That in turn gave rise to Spark from the AMP lab, and Matej Zaharia was one of the lead in developing this, and Spark started in-memory computing. So we moved from disk computing. So here's the CPU right here. So here's where the disk is. So from here, we migrated over here. We use commodity hardware and commodity RAMs, and we have distributed computing framework in memory. So that speeded up a whole lot of things, and definitely we had much, much better performance with machine learning algorithms. Then we have CUDA cores and other things. NVIDIA stepped up. So we are closer here, very close to CPU right now. So we started off with GPU. Then we had clusters of GPU pods with NVLink switch for extremely fast communication between them. And more recently, we have specific hardware accelerators that are kind of cost effective in some manner, competing with GPUs, maybe even field programmable gate arrays, FPGAs, and other architectures coming into play. So we definitely got really fast moving from left to right. We also got very expensive moving from left to right. In fact, NVIDIA's DGX A100 cluster comprising of 8 GPUs was priced at $200,000 some time back. So do we want to buy these and keep it on-prem? So is this worth the investment is something that we need to ask. So empirical studies, scaling laws. So these are empirical studies in the sense I have not seen personally proofs on how these language models should scale, large language models scale, but there's definitely evidence out there based on empirical studies and testing on specific LLMs that larger models perform better and they are kind of sample efficient in some instances. And there's also importance on bigger models as opposed to bigger data. Then there were other concerns, subsequent studies that said that some of these studies, maybe the choice of performance measure in assessing some of the emergent abilities of these models might kind of factor into the conclusions. And also redundancy within the data constrained models, as well as decreasing value with repeated tokens and access parameters could factor into some of this performance that's been claimed. So this is still an open problem from my understanding, but I'm not abreast with all the literature. I'm sure it's rapidly evolving with time. But this paper that came up year back or a couple of years back, it really shows a surge in the size of the models. We started off around millions around 2010 and moved on to like billions and closing on to trillions. So do we have access to infrastructure to support these models? If I need to store models with billions of parameters, those parameters will have to be distributed, and they need to be distributed across GPUs. How do we do it? Do we have the money to buy these things? So workforce, LLM is definitely a team sport. We have multiple teams. We have lots of people from different groups, divisions in this presentation. For instance, as you introduce yourself, I did see people from IT, people from leadership, and people from other data science and other groups. So we have information technology. We have data scientists, engineers, architects, security experts, as well as assist in the deployment of these models and making them production ready. Then we have domain experts, AI, ML, NLP, as well as clinicians and other healthcare staff who assist in the reinforcement learning and the augmented framework. Then we need to have ethics and regulatory expertise, compliance, as well as those who can assist with the governance and establish the necessary guardrails for these models. Then we need to have an environment and culture that is conducive for innovation and believes in evidence-based culture. So there's value in this. So let's go ahead, invest and see what happens. So all these are very critical. So here we have the different silos that work in concert in some sense. So we have the design phase, when we have the develop phase, then we have critical assessment of the models, then we have deploy and demonstrate value. So this is where we exit what is termed as a hype cycle. So there's a lot of talk about LLMs being claimed as super good and not really delivering towards the end. So demonstrating value, impact on outcomes and KPIs would be really critical. So all these things definitely need to be monitored, managed, and refined in an iterative manner. So we talked about digital readiness, we talked about infrastructure, then we talked about workforce. So can cloud computing assist us? So in this, definitely cloud computing offers pay-as-you-go, as a service offerings and models that we can tap into. So we use resources as needed and release them back to the cloud. And we talked about horizontal scalability, vertical scalability in terms of compute. NVIDIA, for instance, sought after GPUs for LLMs. They might have a Tesla GPU, they might have A100 GPU, and there might be H100 GPU. We can't continue to purchase these things on-prem. So the best possibility, if you want to experiment at least, is to kind of have some entity that would give us access to this. And if you don't see value in those, we just move away. So, and workforce, so is there a guaranteed budget to sustain these things for AI, machine learning, Gen AI efforts at health system? So can managed services from cloud service providers complement on-prem expertise? So as to build, deploy, as well as manage enterprise solutions where we don't have to have dedicated workforce on-prem. So complement the workforce demands on-prem. So if we are not digitally poised, again, we don't have that kind of leverage and bandwidth and budgeting. So we might as well tap into some of these cloud-based infrastructure. So eliminate maintenance and infrastructure. So there's a lot of talk about no code, low code. So we tap into these managed services. So we don't have to go into granular details about the implementation, debugging and troubleshooting some of the challenges, as well as worry about infrastructure aspects. So private cloud confidential computing is coming up in a big way. So cloud provides trusted execution environments, but TEs, abbreviated as TEs, that definitely provide privacy, the necessary privacy to handle and work with healthcare data sets. So onboarding pathways, LLMs, making them more equitable, as well as assisting strategic adoption of these models. So the three different models that we talked about in our recent work is train from scratch pathway, where LLM is trained from scratch using healthcare data from an organization. So subsequently, this model can be customized for specific needs and tasks. And then we have the fine-tuned pathway that uses an existing pre-trained LLM. And oftentimes these pre-trained LLMs are pre-trained on non-healthcare data sets. And because sharing checkpointed models is usually not encouraged in some sense, but there might be instances where it could be possible. And as was brought up earlier, the prompt engineering and other factors could play a critical role here, especially if it's a pre-trained model, not pre-trained on the data sets that is coming from an healthcare organization. The prompt engineering efforts and making them work seamlessly and deliver better performance can be challenging, that aspect. Finally, the out-of-the-box pathway is you access the LLM through RESTful APIs or through the web, and they may support additional functionalities such as RAG, where we kind of provide the LLM with some of our own data sources. The LLM kind of adjusts itself and retrains in some sense and kind of is able to kind of accommodate this knowledge and respond to it. So these tracks are not necessarily independent as shown here. So it might be possible to upgrade. So you go from a less complex model to a more complex model. All these switching would definitely depend on the evolving needs of healthcare organization, as well as value proposition. Are we getting value out of these models? Do we want to switch? Do you want to upgrade? Do you want to downgrade? All these decisions have to be made. So at this point, are there any questions?
Yes, there is a question from Sean about parameter quantization. Do you want to ask that, Sean, now, or do you want to wait for a bit till Radha finishes the next couple of slides?
I think that I just wanted to touch on one topic, Radha, which is you mentioned the primary size of the foundation models, right? So ChatGPT or OpenAI, Gemini, things like that. There's a lot of work going on the open source side with things like Mixtral and Microsoft Phi, and also the the Alpha Ollama or Llama 3 on that side. It seems like there's a huge number of options, both for foundation, which is the huge models, and then the middle-sized models, which are performing nearly at the same benchmarks. And I was wondering, how do you evaluate between frontier versus foundation models?
Yeah, those are good questions, Sean. So unfortunately, I don't have a good answer for you. So I met this big person from Microsoft yesterday. We did have a conference, and I had attended. I had posed these questions to him. So a GPT-4o is performing well, is performing great, and you don't have to train models. That kind of defeats the purpose. Pre-trained models do great. So it's just that I'm still having a hard time believing that. And I do know, so the performance, when people say my model is performing better than yours, what is the criteria that they use? And so I know there are some open data sets and there is some performance metrics shown, but unless we put it in a healthcare workflow, it's very difficult to gauge how these models will behave. And with regards to quantization, I still need to take a good look at that. So considering the LLM to be a dynamical system, so as long as there's no feedback within the system, so if I take recurrent neural networks, there's feedback. There are two types of noise that can go on in these dynamical models. So one is when the noise, the quantization noise, if it's coupled to the system's dynamics, its behavior can be fairly erratic. So as to how it adjusts for the quantization adaptively as it goes through, I was informed that the transformer architecture doesn't have feedback. So that's good news in some sense. So if there is feedback, then we are going to have trouble. So that is something. So these are things that I hear from people. Quantization, we are using this kind of quantization. By quantization, I hope you were talking about that. The 16-bit, 8-bit, or were you referring to that quantization?
Yeah, I apologize. I didn't want to get to that level of detail, but some of the cases where they're doing the quantization reduction, we're getting much smaller models, but they're operating at near equal benchmarks like with the foundation models. And so it seems like that in healthcare, where we may not have the capacity or infrastructure for or want to share our healthcare data into a foundation model, that these could be options.
Yeah, so if it's an open source, whether it's enterprise ready is something that we need to definitely seriously consider. So because if it's crowdsourcing efforts, so there's no accountability as such. So they provide the models, they develop the models, and I was an open source chair at EMEA, so I'm a big proponent of open source, but I see some challenges too. So as to the performance of those models, I'm still having a hard time how people benchmark these models, and what is the holy grail of benchmarking, so to speak. So should I believe this because you're telling me this model performs better than something or equivalent? So that's something I still need to come to terms with. So I'm having a little difficulty there. So I know there's a lot of literature and there are performance measures being shown, but I still, so if I go back to the slide, so that's what I liked about this. So here, the scalability, for instance, scaling laws, which is very much kind of in some sense, at least tied to your comments. So here they were talking about choice of performance measure and assessing emergent behavior from smaller to bigger models. So we're choosing the wrong performance measures, things like that. So it's still, it's a lot of things that are in discussion, but I completely understand. I think that smaller models might have the ability to kind of perform better. But I'm thinking that there are things that I cannot discuss now, but because we are working on it. But there are some people who don't have a lot of data, and then there are some people who have lots of data. So the question is, how do we kind of democratize these things across so that everybody gets access to it? Do we need to go with smaller models, giving smaller models to people who don't have a lot of data? Or do we need to get bigger models and kind of do something else? And so there are things that we are talking about, we are discussing. If that's of interest, I can reach out to you. So it's still kind of at its infancy, but definitely there are lots of startups also coming out there that talk about the size of the models and saying that smaller models are kind of performing well and come to us. They provide smaller models and they do well. And so those offerings are out there. So I completely understand, but it's just that I still need to see clear evidence as to which one is better. So I'm still grappling with it. Yeah. So, okay. So with regards to benefits, enhance quality of training data. So we own the data. It's our data. We have an enterprise governance team that oversees this whole data process and approves the ETL, extract, transform, load. So everything is completely transparent and we own the data. So that's very, very important. So training data reflective of the population that we serve. I might be serving a population that's a rural population that might not have anything to do with the urban population. So I'm very much well poised if I incorporate those signatures in my training process. So expected to improve impact outcomes as well as KPIs. So if I train the model on the data from the population that I serve, it's highly likely that I might be able to impact outcomes in a better manner. So enhance transparency of the LLM implementation with regards to architecture, whether I'm going with transformer architecture or I'm taking the baseline architecture, modifying, dropping some layers, or doing something, I know exactly what's been done in terms of the architecture. So the model ownership, customization with evolving needs is possible in this scenario. Does not depend on open source commercially pre-trained models. So we'll come to that again. So with regards to risk, definitely demonstrate digital readiness, as we talked about, infrastructure and workforce, regulatory compliance needs, challenges, and readiness, as well as demands access to large data sets for training these models. Some of the efforts out there have taken the healthcare data and supplemented it with other biomedical data, such as those from PubMed and other sources. So having this enterprise data warehouse would also imply that there needs to be upfront investment in terms of supporting teams, in terms of supporting these efforts. And TSP may demand experimentation. So where do I checkpoint the model? Is this sufficiently trained or do I need to further train it? Where do I draw the line? So that in turn can incur some delays in deployment. And definitely it will there needs to be expertise across a spectrum of areas to embark on this training from scratch. We need to constantly, in an agile manner, engage with different teams, as well as protected time for clinical staff to be a part of the reinforcement part, reinforcement learning part. Then we have the cost of infrastructures, definitely hardware accelerators. We need them for the compute. as well as there could be risks in sharing the eventual checkpointed models, because these models, as much there's a lot of talk about generalization ability, they also memorize information. So economics of training a single run. So we took the Llama study snapshots shown here because they really clearly outlined what is the GPU memory, how many GPUs they use, and how many days they ran. So if we choose, for instance, a Google Cloud Platform, we have to choose the GPU, the type of GPU that we want. We need to choose the memory, and we have added things that comes along with it, and we have the pricing. So do we need to go for hourly pricing, monthly pricing? Do we need to go for on-demand, on spot instance? So on-demand commitment, 1-year commitment, for instance, plugging these values in comes to around $4.7 million, which is fairly staggering. So usually when we embark on these efforts, if you were to lead a team, when you come in and take over these things by the reins, you're going to look at least a 3-year to 5-year commitment from the health system leadership, executive leadership. So in which case, it can really trickle down. So it will definitely be in millions of dollars, but as you see, it drops down. And if we were to opt for spot instance pricing, so it further drops it down. But then there's always a trade-off with each of these approaches. So which cloud service providers? So I should state here, as for pricing options, the cloud service providers are more or less very similar. So as much as I'm showing the GCP, I was able to map his parameters that's shown on this paper directly to GCP for no other reason. So the pricing as such is very compatible across cloud service providers. So which one to choose? So so compliance and security, extremely important in healthcare. So is the cloud service provider HIPAA compliant for handling PHI data? Do they support identity access management as well as encryption? And do they have confidential computing frameworks and environments that we can tap into? AWS, for instance, has Nitro enclaves, and Google Cloud Platform has Kubernetes nodes for supporting confidential computing, and Azure has other Intel SGX and other hardware to support that. And with regards to compute, all of them support NVIDIA GPUs sought after. In addition, AWS, for instance, also has their own hardware accelerators, Trainium, Inferentia, and Google Cloud Platform has TPUs, tensor processing units, and Azure has Maya 100. So managed services, they all offer different types of managed services that we can tap into, so that can complement some of the on-prem workforce demands. And with regards to LLMs, as was noted previously, AWS taps into the Anthropic Cloud LLM and Google Cloud Gemini family of LLMs and Azure GPT family of LLMs. So with regards to fine-tuned pathway, we saw about the train from scratch pathway. We spent a fair amount of time for good reason, because that's something that we need to give serious thought. With regards to fine-tuned pathway, it uses readily available pre-trained LLMs. For the most part, these LLMs are pre-trained on large data sets that are available publicly. So this could be Wikipedia and other sources that are out there, and so that could have some demands with regards to quality and other aspects. So there's a variety of pre-trained LLMs, as was noted. There is small models, there's large models, and Hugging Face has all these leaderboards that constantly rates these models. People can go and see, last week this guy was topping the charts, this week another guy is topping the charts. We're not going with them anymore. So there's a lot of excitement in adopting these models, and there's a lot of options here. So there's reduced commitment in terms of data infrastructure as well as workforce relative to TSP. And definitely it can avail offerings such as APIs from cloud. As for risk, the choice of pre-trained LLM, especially those pre-trained on non-healthcare data, can impact their performance. So how can we make them context specific? And proprietary LLMs may have some locks on how much we can tweak them. And there could be definitely some boundaries where we cannot cross because it's proprietary and there is minimal transparency and there's lack of ownership. This could factor in as the demands of health systems evolve with time, where in which case there might be a need for us to move things. For instance, there might be an LLM that might not support voice to text. We might need to incorporate voice to text, where nursing staff might need to walk and talk, and it might not be possible to transfer that on a mobile device. So any kind of challenge can arise. And downstream tools, would we be able to incorporate this into downstream tools? Those challenges can arise. And training data and pre-trained LLMs can be prone to quality issues, as we noted. So it's not like the data has gone through a governance and has gone through the ETL that's been approved by a enterprise governance committee. This is maybe tuned on publicly available data and may be prone to performance issues. And prompt engineering efforts can be fairly detailed when it comes to using pre-trained models, and can be more involved. And translating open source tools to enterprise tools. This this came up in Sean had raised, in fact, some of the tools out there. So there could be security risks, there could be vulnerabilities, dependencies that we are not aware of in terms of versioning and other issues, as well as crowdsourcing efforts or voluntary efforts. So I might feel like contributing to the open source community today, I might not feel like it tomorrow. So that's how it goes, right? So, and there's integration challenges with downstream applications. So we have these tools. Would it be amenable to integrate with downstream applications? So finally, the out-of-the-box pathways, benefits, access through web interface, cloud-managed API endpoints. It also provides additional functionalities like RAG, which is very, very applicable, and there's a lot of excitement around it, and especially suited for onboarding organizations. If I'm an organization, I don't have the digital and analytics maturity. So this would be a good point for me to jump into the wagon, the LLM wagon, see whether there's any payback or there's any return on investment, or am I able to impact outcomes. So minimal learning curve in using these. So it's readily available. There is usually no code or low code. There may be an option for low code, and anybody should be able to use it. They might be able to import their data and push it in the RAG framework and sync it with the LLM that's in place, and the RAG is automatically trained. And then we just have to work with the prompt engineering and establishing guardrails. Then it should be ready to go. So enterprise ready with minimal upfront costs. So there's no digital readiness as much as what is required for the other two, infrastructure as well as workforce demands are minimal. Risk, there's complete dependence on the managed services. So because tomorrow the cloud service provider might pull this LLM or the managed service out and might provide another one that might not match in many respects. So there's no transparency of data, no transparency of models. So the cloud service provider might not make it available. So open source, definitely there's transparency, but that would entail standing up a server, supporting all the things and ensuring all the privacy and other aspects are guaranteed. So minimal customization of managed service. So usually these come hard baked. So there's a window and there's an interface. So there's nothing much we can do with the fonting, with the aesthetics. So most of these might not kind of really, it's not amenable to a lot of changes. And again, downstream applications, would we be able to integrate into that? That's something that we need to think about. Definitely can assist with generic clinical knowledge. RAG can assist with some more context-specific knowledge, but for the most part, this would be helpful for generic clinical knowledge. So what are the symptoms accompanying COVID, for instance? We can pose questions like that, but I cannot ask, in this county, for this age group of this population, what was the last month's kind of admissions or kind of appointments or telehealth appointments? I can't pose questions like that. So there are some challenges as to how much granular we can go with these models. So OBP cost might look very trivial and kind of appealing upfront, but as we incorporate, as we use the OBP for more and more independent projects and applications, so the cost is going to increase. Definitely the cloud service providers do provide slabs based on the number of users. But then, as was brought up earlier, the input-output token size, all these things can impact, and the users need to be trained so they just don't continue to input a lot of things and continue to bombard the LLM with too many inputs, and that in turn can spike up the cost. So there needs to be training on the usability of these. So in summary, so we did talk about LLMs, and we acknowledge that they have a lot of impact. Could have a lot of impact on healthcare delivery and outcomes. Equitable adoption and democratization are extremely critical, especially across organizations serving diverse communities. This is critical because that would entail widespread adoption, demonstrating value as well as transforming the healthcare landscape and completely steering away from rich get to richer cascade. So LLM implementation and deployment is dependent on needs as well as affordability. We talked about essential ingredients with focus on digital readiness, infrastructure and workforce, privacy, ethical and regulatory considerations. And LLM implementation and adoption, unfortunately, does not subscribe to one size fits all. We presented 3 onboarding pathways, trained from scratch, fine-tuned pathway, as well as out-of-the-box pathway, with risk benefits as well as economics across cloud service providers that in turn might encourage equitable and strategic adoption. The next steps for us is definitely to explore alternative solution and discussing with experts such as yourself and getting feedback. I got some feedback in today's presentation from you, so definitely, and also connecting to others nationally, including healthcare leadership and industry partners, to see how we can make this more affordable to the larger community. Happy to take any questions.
This is great, Radha. Thank you very much for your presentation. I do have a question. So what is CHOC doing right now? What are you guys using out of these 3 pathways? What do you find to be most successful? And in particular, what are a couple of your really successful projects around this?
Absolutely. Thanks for the question. So at CHOC, we are using LLMs. It's at its very preliminary stages. So because we are also going through the process of revamping our data warehouse. So we are using Microsoft Copilot widely across the organization. But for clinical aspects, we are exploring OpenAI, as well as Amazon Q Business, as well as Bedrock. So, and these are the 2 things. And we also have some consultants that assist us from outside on certain specific projects. The projects that I am kind of handling here includes using managed service, Amazon Q Business, within a RAG framework to assist with nursing policies and procedures. So they have this policies and procedure assistant where nursing can go and access and put some questions as to what is these policies and search those policies by keywords. But on demonstrating to the nursing team, they felt that if there is a chat interface where nurses can post questions, that would be much more useful than just more like a keyword search. They still think of this as a search and retrieve tool, but I'm trying to kind of emphasize to them the summarization part is fairly non-trivial. The search and retrieve is more like a string matching, approximate string matching, regular expressions. We can use things like that, but to summarize context in a context-specific manner, that takes a certain amount of intelligence. So we are using RAG framework, and we have gone ahead and implemented it. There's a blog post that we posted in Medium recently, where we kind of pushed the limits a little bit on the features with regards to Amazon Q Business, because the key with the RAG is that when you click on those citations or the documents that are being referred in the LLMs output, the summary, we should be able to see those documents. But due to some identity access challenges and between AWS S3 bucket and Amazon Q Business, there were some challenges. So we sought about a roundabout way of doing that. So including ingestion from other sources. So we are able to address that. So yeah. And there's also translation projects. So because some of the communities that we serve, it's English, they are non-English speaking communities. So some of the discharge instructions and other things are much more valuable to those communities if they can be in their native language. So the translation project is something that I don't lead or not involved with, but that is something that's also going on.
That's awesome. We were talking about it just this morning, that a lot of material is translated in the top 5 languages, but then there is this long tail of languages that we still need to translate. We may have time for one more question. Yeah, Sean.
I don't mean to chew up all the time, but I'm so curious. One of the big challenges we have in clinical care is the regulatory and the really the heavy centralization of our workflows within the Epic EHR system. Can you speak to kind of how artificial intelligence and tools that we would be building could be used in a controlled environment like a clinical delivery, and how to look at how to either bring them into the EHR or connect to the EHR, which is where most of our work happens?
And to piggyback off of that, I also want to read out Ian's question in chat because that's his first question today. Will EHR vendors like Epic be building their own LLMs into the product that they will sell? So that's kind of tied to what Sean is asking.
Yeah, absolutely. We are Oracle, formerly Cerner shop. So Epic, when I was at Cedars, they were on Epic. From what I had seen, Epic is very amenable to a lot of interaction with cloud. That's what I'd seen, because we used to have next-gen sequencing data moved from Tempus onto AWS. And we used to have AWS step functions that go through that data and execute certain functions, whatever needs to be done, and push those results back into Epic. I don't remember whether it's Clarity or Caboodle or one of their interfaces. So Epic, from what I've seen, is very much open for innovation. With regards to how do we deploy in clinical workflow, we always have to work from the clinic backwards. So the LLM part itself is very complex. But that's the easy part when it comes to clinical deployment. So we need to have like sponsors, and we need to have people who would kind of, take this to the high level leadership in the clinical teams and kind of carve out what needs to be done so that this could be facilitated. And we need to be guaranteed that it's going to be adopted. As for building the interface in terms of clinical data support, in terms of messaging, whether it goes to FHIR interface or HL7 interface, or how do you interface these? I don't know, Epic, whether they provide hooks directly. Sean, I know that you had mentioned about open source tools. So will Epic throw hooks onto those open source tools so it directly ingests from there? So those are things that I don't have much information. But as for the question, Ian, with regards to Epic doing their own thing, I think it's a very, very high possibility, because don't quote me on this, but I think there is some Oracle, I think there's a lot of movement in them revamping their EHR. And somebody told me, I don't want to be quoted, that they might even use Gen AI tools to improve the EHR functionalities, and maybe because Gen AI tools are writing code and doing things like that. So lots of excitement is going to be there. So the LLMs would come inside Epic definitely at some point. I know that with Microsoft, there is some collaboration, if I understand right, between Epic and Microsoft. Is anybody aware of that?
I think there was a news item to that effect.
There's some post here by Shane.
Yes.
Yeah, definitely. I don't know all the details, but there's going to be a lot of evolution on the EHR front. I would not be surprised Epic I think that the open source part is only thing that, I mean, it provides a lot of innovation, but would we want to play with enterprise healthcare data with the open source is something that everybody needs to be kind of comfortable with. With regards to cloud service provider, there were a lot of difference when it first came into existence. Can I let my healthcare data reside on the cloud? But we have overcome that hump, and there's a lot of movement, a lot of push towards cloud. But then, with regards to open source, would that also be the case where healthcare comes forward and says, we'll open the doors, so let's interact with open source? And we consider open source as enterprise ready, because a Log4j and some of the things that had happened, like the vulnerabilities and things like that, it's not very kind of good news overall. So those were considered to be like kind of benchmarks and kind of foolproof. But yes, you can put it within a firewall. You know, this side of the firewall, nobody can do anything and protect, completely sandwich it. How's it inside a nuclear reactor? So that's another option. So I don't know. So so we have a security expert, right? Mike, did you say you were leading the security?
Thank you, Radha. Before before I let Mike answer, let me just formally end our session today because we are 4 minutes past. But a few of us, if you have time, please feel free to hang out and continue the conversation. So I'm going to stop the recording, or I'll continue the recording in case people want to hear Mike's answer. So whoever wants to hop off, please do hop off. We will formally conclude the session, but we'll continue the conversation with those who can stay. Mike, please. Sorry.
Okay, I think I would push back on the supposition that you're completely secure staying inside the firewall, and that all software has its potential vulnerabilities, including open source. And I'm, to a great extent, supportive of the fact that you have more eyes on open source software. You know what you have. You have the bill of materials to a much greater extent than you have with proprietary software. There are trade-offs with everything.
Absolutely, completely agree. Yeah.
So if we have on-prem instances of open source LLMs, will you be happy?
Is this for Mike? Question for Mike?
Yeah,
yes,
for Mike.
As with all, it's the classic answer. It depends. That's all you'll get from me today, Sanal.
That doesn't help me do my work.
No, I know. I appreciate that. Everyone would like easy, direct answers from information security.
No, security is hard because you have to take responsibility, right? Like the buck stops with you if there is an issue. So that, like, I think everybody understands that it's really hard.
Well, when it comes to considering, what is secure and reliable use of LLMs, everyone's got their challenges.
And you can query the data to extreme granularity. For instance, the RAG framework, I just posed a question. Who wrote this procedure? That was an irrelevant question. It goes inside the PDF and it says Barbara Clay or somebody. I was like shocked. I mean, it picks every nuance. I think these models, don't quote me again, are overfitting the data. I'm very sure that they are memorizing things. I have no qualms about it. I ask people, I've never gotten a good answer about the convergence of these models. So everybody says stochastic gradient descent, optimization. So I don't know.
And that is why I want to push back a little bit on giving an answer. So when we were talking about RAG, sometimes it is really helpful to provide the sources, because if you just summarize and give the final answer, then you really don't have that transparency as to where the answer is coming from. Whereas, like, along with the summary or a final answer, it's really helpful to give the original sources, and then especially if they're clickable and, like, user can actually go to the source and read it with their own eyes. That is sometimes of value.
Absolutely, I completely agree, because that's the validation part, right? I mean, so the LLM won't know what I am needing in terms of summary. It's generating what it thinks is a summary, but it might leave out details because the summary is succinct. So, and so that might not capture every facet that I might want from such a summary, because it doesn't know what I am thinking. So the reinforcement, as you mentioned, so the nurses go back to the document and give a feedback. Right now, there's a thumbs up or thumbs down sign. It could be much more better in Amazon Q Business. So that's the reinforcement learning part. So they give a thumbs up, then the LLM knows it's delivered a good response. It stores it for future. But if it gets a thumbs down, then it knows that it needs to work harder or do something different.
I had worked on a very similar project for our regulatory team. So where the documents come from, like, because regulations are so complex again, right? So like you take a bunch of regulatory documents and do the PDFs and create a vector store out of that, and then a RAG-based interface. And to your point, Radha, about even if you use standard LLMs, you can still build an interface in Streamlit or something that can be custom. So you can have, like, under the hood, you can have something that is, like proprietary, even OpenAI or something like that, if it is secure. But then the interface you can always customize.
Yeah, I need to discuss about that in detail sometime with you. Yeah, but I agree. Streamlit is very good too.
Yeah.
And it's very fast, even in merging large data sets and all that, because of the Python backend. I think it does super fast.
Yeah, under the hood, it's Python basically.
We went once like a competing Tableau with a Streamlit, and found Streamlit to kind of outdo Tableau. It's not even in the same ballpark. And Tableau also has some quirks in the sense it won't let you customize, and just creating a Venn diagram is so difficult sometimes. I would hope that we should be able to just pull things and put it, but it requires, more training. I mean, I don't hesitate to dabble because I'm a hands-on coder. So irrespective of my positions and whatever I've done, so I like to get into the trenches and do things. So with Tableau, I found that it's not fairly straightforward. That would be a learning curve.
That's right.
Okay, we are now 10 minutes past. Thank you very much for staying the extra time and for your talk, Radha. We do have the recording. I'll stop it now, but it will be available for others to listen to later as well. So thank you very much for your patient answers to our questions, and thank you for the questions. So bye-bye. Good night, everybody.
Yeah. Thank you very much. Thanks for the opportunity and the company and questions. Thank you.
Okay.
Thank you.
Fabulous. Thank you. Bye.
Thank you. Bye.